In this video, we're going to take a look at scientific notation. Scientific notation is a way of writing very large or very small numbers. And when you use scientific notation, all the numbers are written in the form a times 10 to the power of k, where a is between 1 and 10. It can equal 1, but it cannot equal 10, and k is an integer. In other words, it must be 1, 2, 3, 4, 5, 6, or negative numbers. So an example is 700. That's just a number. If you wish to write it in scientific notation, it would be written as 7 times 10 to the power of 2. A is 7, it is between 1 and 10. K is 2, it is an integer. And the second number, 4,900,000,000, would be written as 4.9 times 10 to the power of 9. A is between 1 and 10, and K is 9, which is an integer. Let's go through some examples. So example 1, write in the form a times 10 to the power of k. A, 725,000,000,000,000. So the first thing you need to do is put in the decimal point. So the decimal point is there. And now we need to move the decimal point to the left so we get a value between 1 and 0. So we move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces. So we can now write 7.25 times 10 to the power of 11. So 725,000,000,000,000,000 written as standard form is 7.25 times 10 to the 11. B, write 0.0000000000172 in standard form. Again, we're going to move the decimal point. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the decimal point would go there. So now we could write 1.72 times 10, and because we've moved the decimal point to the right, it is negative, so it's minus 10. So 0.0000000000172 in standard form would be written as 1.72 times 10 to the minus 10. Question 2. Write out the number in full. A, 4.26 times 10 to the 6. So write down the A part, 4.26, and then put as many zeros as you want after it. You can always add more if you haven't got enough. Now move the decimal point 6 spaces to the right. So it goes 1, 2, 3, 4, 5, 6. So it'll end up there. So the number in full is 426, 1, 2, 3, 4 zeros. C, 5.7 times 10 to the minus 5. Again, write out the A part. So we've got 5.7 Now, but because it is negative, we're going to move it to the left, so we need the zeros in front. So put plenty of zeros. And now we're going to move the decimal point 5 spaces to the left. So it goes 1, 2, 3, 4, 5. So our number would be 0.4 zeros, 5, 7. So 5.7 times 10 to the minus 5 in full would be written as 0.000057. These can also be done using a GDC. I've opened my GDC at a calculator page. If I type in 375,000, press enter, nothing changes. But I can get standard form by pressing Documents, 7, 2, and changing exponential format to scientific, calculation mode to approximate. OK. Now if I type in 375,123 and enter, it gives it me in standard form. Not solely recognizable at the moment, but that does stand for 3.75 times 10 to the power of 5. The E stands for times 10 to the power of 5. This format would never be used in an exam or in a maths IA. You must write that as 3.75 times 10 to the power of 5. And similarly, if I put 0.000175, press enter, it gives it me in standard form, 1.75 times 10 to the power of 7. If I change it back now, I go 7, so Documents, 7, 2, change it back to normal, back to auto, OK. If I type in 2.3, E is this double E, to 12, and then press enter, it changes it into a normal number. So you can go both ways as long as you've got the correct settings on your GDC. Question 3. Jupiter has a radius of 6.99 times 10 to the power of 4 kilometers. Assuming that it is a sphere, find its surface area. Well, the surface area formula is 4 pi r squared. That is in your formula booklet. So the surface area is 4 times pi times brackets 6.99 times 10 to the power of 4 squared. I'm going to use my GDC to find an answer to that. So I'm back at my GDC, so I need to type in 4 times pi times brackets 6.99 e to the power of 4, come outside the brackets, I want to square that and press enter. So my final answer is 6.13994 times 10 to the power of 10, which would round to 6.14 times 10 to the power of 10. Write down the final answer, which is 6.14 times 10 to the power of 10. So the surface area of Jupiter, assuming it is a sphere, is 6.14 times 10 to the power of 10 kilometers squared.